It's Aaron. Today, I'll be talking about a journey into the world of machine learning with TensorFlow.js. So who am I? Well, I'm Aaron Ma. I'm 11 years old and I have tremendous passion in computer science ever since I was 5. I'm a hardcore software and hardware developer, and I'm the world's youngest TensorFlow contributor. I'm the world's youngest graduated from UNASI's self-driving engineering program, and much more. And you can follow me on Twitter at AaronHMA. So every day when I go to my computer, I always go to google.com to see today's doodles. Some of these doodles celebrate an event. For example, when France won the 2018 FIFA World Cup. Some of these doodles celebrate a festival, like Children's Day 2019. Some of these doodles are just fun to watch. But this doodle is my favorite. This doodle celebrates the birth of Johann Sebastian Bach, and it's at his best ever. It's the world's first artificial intelligence-powered doodle. Let's take a look at this. So as you can see here, there's a very cool open box experience here. So once the box has been opened, you can start randomly clicking notes here. Then you can click Harmonize, and the in-browser machine learning will automatically add notes to your composition to make your composition sound like what Bach would have played it if he was alive. Once it's done, you can download it, share it with your friends, and also edit it. In only 3 days, more than 50 million people have interacted with this tool and reached every single continent on Earth except Antarctica. And it also became a social phenomenon when it was trending on Twitter. So why was it so successful? Well, because the in-browser machine learning allowed highly interactive experiments to take place on various devices. Plus, there was no drivers or installations in the process, and also it's secure, since all the data stays on the device, so users know they have a secure connection. So this doodle is powered by TensorFlow.js. So most of you here at ng-conf Hardwired are Angular experts. With the touch of the magic of machine learning, you can make your web app Angular and machine learning powered. Plus, customers will love your ML powered web app. So what exactly is machine learning? Well, it's a study of a complex algorithm in statistical models. It has the ability to learn and improve from its own experience without being explicitly programmed, without any human intervention or assistance. The goal of machine learning is to find the algorithm along with the weights and biases by tweaking the input hyperparameters. So machine learning is not magic. It's rather using technology to answer questions based on data. So on the left-hand side of the machine learning pipeline, we gather our data and apply a pre-processing technique to the data to make sure it is in a suitable format for ML. Then, on the right-hand side of the ML pipeline, we can apply a learning algorithm to the data and then train our model. When training our model will learn the relationship between the dataset and the answers. Finally, once the model has been trained, we can test our model to see how well the model has learned a dataset during training. So let's take a look at that in a human-friendly way. So let's meet John. John loves listening to new music. He loves music that has a fast tempo in the genre rock, but he dislikes music with a slow tempo in the genre pop. So we can plot his like music and dislike music on an XY axis graph, as you can see here. The x-axis is the music genre, from pop to rock. The y-axis is the music tempo, from relaxed to fast. So let's say John's listening to a new song, Master of Puppets by Metallica. Where do you think the point will be at? If you guess the point was somewhere here, you're correct. How about Bad Guy by Billie Eilish? Where do you think the point will be at? If you guess it somewhere here, you're correct. But what we can do here is use a machine learning technique known as k-nearest neighbors algorithm, or KNN. What this does is draws a circle around our data point. Now we can safely go majority and say that John would probably like the song. Now let's talk about traditional learning versus the new machine learning program. So in traditional software development, we already know the input and the algorithm. We just write a function that gets the output. But in machine learning, we take in pairs and pairs and pairs of input and output data. We write a model that figures out the algorithm. You may notice in traditional software development, we're more focusing on our code. On machine learning, we're more focusing on how data has been represented. So let's take a look at a simple scenario of that. Hello, hola, bonjour. There are so many languages to say hello. So in traditional software development, let's write some code that, based on the text, knows what language it is. So in English, it's hello. So if the text is hello, then the language is definitely English. In French, hello is bonjour. So if the text is not hello, then the language is French. In Spanish, it's hola. So if the text is not hello or bonjour, then the language is definitely Spanish. But what language is this then? Hello, what language? Oh no! Our model has no idea what that means. So the problem was that in traditional software development, we explicitly say every single possible scenario that might happen. So by the time you're done with that, you'll be like this. But then you realize, oh no, there's so many other phrases that you ever write, like what's your name and goodbye. Now what? Well, let's use the magic wand of machine learning. To start off, we'll gather a dataset and then train on that dataset. In training, our model will learn a relationship between the data and the answers to get out the rules. So let's run it again. Hello, what language? And our machine learning model has a prediction that is 92% it's Chinese. So we can safely go and say that the language is probably Chinese. Much better. So now we're thinking, which machine learning library should I use? Well, I got you covered, friend! So the top 3 machine learning libraries as of today are TensorFlow.js, RangeOS, and ML5.js. Let's take a look at statistics, as statistics never lie. But clearly, TensorFlow.js wins in almost every single category. How about Google trends in the past 12 months? Clearly, TensorFlow.js is the winner. How about NPM downloads in the past 3 months? But clearly, TensorFlow.js is still the winner. In fact, as of March 29th, the downloads is almost 3x over Brain.js downloads. So the winner of the machine learning JavaScript library battle is, drum roll please, TensorFlow.js. Yes! So TensorFlow.js contribution in the past 12 months has skyrocketed. There's more than 1.4 million NPM downloads and 10 million CDN hits. So now you're thinking, what exactly is this TensorFlow.js thing? Well, it's an open source artificial intelligence platform that allows you to develop machine learning models writing in JavaScript and use machine learning directly in the browser or with Node.js. And it's designed to be consistent with TensorFlow, which means it's a complete rewrite from scratch, not abiding TensorFlow, and it can run anywhere as long as JavaScript can run. Plus, it's really fast as it's GPU accelerated. So the term TensorFlow is reflecting what's happening inside the firm, where tensors are flowing through neural networks and other data processing nodes. So a tensor, you can think of it as a type of data structure that is commonly used in linear algebra. It's immutable, but can be calculated with arithmetic operations. So you can think of tensors as just like a JavaScript array, or more like a multi-dimensional JavaScript array. So there are multiple ways to use TensorFlow.js. The first way is to use a pre-trained model directly for inferencing, or use a pre-trained model with the customization of your own data. Or finally, develop and train models from scratch using intuitive and flexible APIs. So TensorFlow.js currently supports 4 backends. There's a CPU backend, which is available for all devices, a WebGL backend, which supports 53% of all devices, and is GPU-based, and a Node.js backend that allows models to run on the server, on the browser, and also Internet of Things devices, and also Wasm, which is CPU-based and allows C++ code to execute in the browser. Finally, WebGPU is coming soon, and it's expected to have even better performance than WebGL. So now it's time to get the TensorFlow.js part into your Angular-powered web app. So let's get started today! You can use pre-trained models directly for inferencing, but I'll cover about that in the next slide. Or convert an existing model to a TensorFlow.js readable format using TensorFlow.js converter wizard. Or finally, you can run same models directly without any conversion in Node.js. So TensorFlow.js provides pre-trained models for the most common machine learning tasks, including, but not limited to, image classification for computer vision, object detection, and speech-command recognition for natural language processing. You can find the source code and a live demo of all of these pre-trained models on the TensorFlow.js models GitHub repository, and you can download them on NPM. Currently, there are 13 NPM packages, but the list is growing every single day of TensorFlow models. So some ideas for web apps along with TensorFlow.js is augmented reality. For example, the L'Oreal company made a virtual makeup and hair color try-on app with TensorFlow.js. And there's also real-time body segmentation. It runs around 25 frames per second on the 2018 15-inch MacBook Pro and 21 frames per second on an Apple iPhone X. So TensorFlow.js is a very vibrant community. There are extensions, libraries, and so much more that are all built on top of TensorFlow.js. Just to name a few extensions, how about Base API.js, Handtrack.js, and ML5.js? Base API.js allows real-time face detection, age estimation, and emotion and gender recognition in the browser with TensorFlow.js. Handtrack.js allows real-time hand detection based on hand gestures in the browser. Finally, ML5.js provides access to more amazing machine learning algorithms and models in the browser, It's all built on top of TensorFlow.js to support an even broader public audience. So you're thinking, how fast is TensorFlow.js? Well, let's use the MobileNet v2 benchmark. On a laptop, TensorFlow.js runs around 20 milliseconds of inference time, while on Apple's iPhone X is around 22 milliseconds. But Google's Pixel 3 needs a lot of improvement, where the inference time is 78 milliseconds. The TensorFlow.js team is actively working on addressing them. How about on the server side? Well, Node on CPU is around 23 milliseconds of inference time, while on a GPU, it's around 9 milliseconds. The performance run on Node is on par with Python on both CPU and GPU. In fact, in some cases, it's even faster than the native TensorFlow. Once you write your TensorFlow.js code, it can run anywhere on a modern browser, mobile device, Node.js, and also Electron and Raspberry Pi for Internet of Things. It truly is a build once, run anywhere philosophy. So let's get started with TensorFlow.js in your Angular application. To start off, create a new Angular CLI application. Then, install TensorFlow.js using yarn or npm. Make sure in your tsconfig.json you set skip library check to true in your compiler options, or else you might get a compile error trying to compile. As with all Google projects, TensorFlow.js provides highly detailed documentation and tutorials on how to get started, and I highly recommend you check them out. For now, consider this your Hello World application in TensorFlow.js. Here, we're importing version and tensor from TensorFlow.js, just like how you would import things from RxJS. Then, on ng-conf function here, I'm console.logging my TensorFlow.js version and a two-dimensional tensor to the browser developer tool console. Trust me, if you can learn RxJS, you can definitely master TensorFlow.js. So now my grand finale, drum roll please! Handwritten digit classification lab. In this lab, we'll build a TensorFlow.js model in the browser from scratch. They'll recognize handwritten digits that we will write with a convolutional neural network. So here's the plan. We'll first train the classifier by teaching it thousands of handwritten digits, images, and their separated labels in a separated binary file. Then, we'll evaluate the classifier's accuracy using handwritten digits that we will write that the model has never seen before. FYI, this lab uses the latest version of Angular and TensorFlow.js. So as with all machine learning projects, you need data. So the data that we'll be using is the MNIST data, or Modifying National Institute of Standards Technology. And there's 65 total images in this data set, and it's all comprised of one sprite. And it's around 10 megabytes. So each of these images is 28 by 28 pixels, and it's all grayscale. So let's take a look at a demo of this. You can either click this link here, but I'll be showing it here. So not everyone can see here. So here's the place where we'll be drawing the numbers between 0 and 9. And the TensorFlow's predicted number will be shown here. So I haven't trained my model yet, so let's say I just write 2. And then say, no model found. Okay, so I train my model with 4 epochs. So you can see that the data is all 28 by 28 pixels in its grayscale. So my visor here, I can see my model architecture and also my model training statistics. Don't worry if this doesn't make sense. I'll talk about it in just a few minutes. So now that my model has been trained, now I can start writing digits. For example, 1. 1. Okay, I guess this doesn't work, but let's just go to 10 epochs. So for 10 epochs, let's say I write 2. And it's predicted it's 2. That's pretty good. How about 3? And predicted it's 9. And how about 9? And it's predicted it's 9. So my model for 10 epochs is pretty good, except for I misclassified one of them. So let's say I train for 40 epochs. Let's take a look at my model again. So I'm just going to write 2. And predicted it's 2. That's pretty good. How about 6? And clearly, my model here for 40 epochs is pretty good. But what just happened there? Well, let's take a look at that. So the first step of all machine learning projects is that you need to clean the data and then load the data. Since the data is already cleaned, we don't need to clean the data. We just need to load the data. So my code, I'm calling the MNIST data class, which you can find the source code at this URL here. So what this class does is fetches the sprite image and returns a shuffled image list. As you can see, all these images are 20 by 28 pixels in our grayscale. One more important thing that this class does is splits data into a training data set and a testing data set. The training data set is a data set that I'm going to use to teach my model, while the test data set is the data I'm going to use to evaluate the performance of my model. So now we need to build my model. To build my model, I'm going to use a sequential model, which by far is the most simplest and most popular model architecture. So my model architecture will have 6 layers. The first layer is going to be my input layer, where I'll feed my data into my model. Then there will be 4 hidden layers, which will perform the required computation for my model. Finally, a hidden layer, which will be the output of my model. So I'm going to add an input layer using the model.add API with a convolutional 2-dimensional layer. What this does is creates a convolutional kernel which produces tensor outputs. So my input shape is 28 by 28 by 1. The 28 by 28 represents the width times the height, and the 1 is the image channel, which is grayscale. I'll also be using the ReLU activation function, which keeps all of the positive values, just basically zeroes out all of the negative values. Then, in my output layer, I'm going to create a dense layer, which you can think of as a fully connected neural network with 10 output units. The number of output units in a type problem like this is basically just a number of classes that you're feeding into your neural network, in this case 10. And I'll also be using the softmax activation function, which sums the tenuous probability distributions into 1, and whatever the probability index is the highest is going to be our predicted number. So now we need to compile our model. We can compile our model using the model.compile API. When compiling our model, you need to set the optimizer, loss, and the metrics. The optimizer is how we're going to tell our model to improve on its accuracy. And the loss is how we're going to evaluate the error. And metrics is going to evaluate the performance of our model. For the optimizer, we'll use ADAM, or adaptive moment estimation, and it's most commonly used for stochastic gradient descent. Let's take a look at that. So as you can see from this slide here, gradient descent, you can think of it as a bowl, and the lowest point of the bowl is our goal. We also need to set a learning rate, which you can think of it as a ball. So you can think of it as a ball putting it into a drain. So if you shoot the ball too fast, it's going right past that drain. If you shoot the ball too slow, you're not going to have enough momentum to get to the bowl. And the loss here we'll be using is the categorical cost entropy, which will measure the error between the probability distribution generated by the last layer of the model and the probability distribution given by the true label. And for the metrics, I'm going to set accuracy. So now we need to train our model. When training our model, we need to train our model on the training data set. In this case, train X, which is our data set, and train Y, which is going to be the training label. We'll also set the batch size to 512, and the user will define the epochs. The total number of batches we'll train on will be 512 times the number of epochs. And the validation data, which is a parameter of the data that we'll be using to validate our model, is test X and test Y. We'll also be setting the shuffle parameter to true, which is going to make sure our data set is not in the given order. So on the graph here, on the first graph here, you can see the lines moving down. That's good, as we're minimizing the error of our model. The second graph, there's a line that's going up. That's telling us that our model is maximizing its accuracy. In machine learning, our goal is to minimize the loss and also maximize the accuracy of our model. So I trained my model on 25 epochs, and this is what I got. I got an accuracy and a confusion matrix. So accuracy, for example, handwritten digit class 9. I fed in 43 image samples to my model, and I got 100% of accuracy. But some of these are not so good. For example, the handwritten digit class 3. I fed in 54 image samples to my model, and I only got around 89% of accuracy. Here's a challenge for you. Try and play around with my model and also the number of epochs trained to get a better validation score than what I got. So now we need to make our predictions. So whenever the user writes something in the canvas, we'll call the pre-trained model and execute the inference for the input tensor, and then convert that to a string and show it to the user back in the UI. So you can find the source code for this demo at this GitHub repository here. So congratulations on making through this talk. Just a few more slides before I'm done here. So currently, there's a Twitter campaign where you can see what the community has made and share your work in TensorFlow.js using that hashtag made with TFJS. As Larry Page, who is a co-founder of Google, once said, artificial intelligence was the ultimate version of Google. Thank you for the inspirational quote about AI, Larry Page. So here's some next step in a machine learning journey. You can see all of these stuff and you're like, which one should I do next first? Well, that's why today I'm launching awesome TensorFlow.js, which you can find at this GitHub repository, which is a curated list of dedicated resources to help you master TensorFlow.js. Now my takeaways of my talk. Machine learning is using technology to answer questions with data, and machine learning is more concept-heavy, and code less. And currently, TensorFlow.js is the most popular machine learning JavaScript library. And getting started with TensorFlow.js is as easy as using RxJS. And machine learning is for everyone. Machine learning is for everyone, which means you sitting in your chair, you can become a machine learning engineer with a little help from Google's TensorFlow.js. Can you hear me? Machine learning is for everyone, and machine learning is for everyone, which means you sitting in your chair, you can become a machine learning engineer with a little help from Google's TensorFlow.js. So thank you for listening. I'm Aaron Ma. Don't forget to check out my cool website, aaronhma.com. Sending you a hi at aaronhma.com. I'm available for 14 hours, 7 days. And don't forget to follow me on Twitter at aaronhma. I'll be posting up my slide deck and all of the demos used, and also regular tips and tricks into machine learning. Thank you for listening, and have a great day.